Please remember that the complete information for the class that you are about to view is at elithecomputerguy.com. Not only do we have our videos there, but we have part lists, diagrams, pictures, and even complete code examples. So if you are watching this video and you want more information, please go to elithecomputerguy.com. Welcome back. As you know, I am Eli the Computer Guy, and in today's class we're going to be creating a time-lapse camera using a 5 megapixel Arducam, an Arduino Uno board, a SD shield, so a data logging shield for our Arduino that has a real-time clock built in. So for today's project, what's going to happen is essentially every 60 seconds the Arducam is going to take a picture. We're then going to save that picture to an SD card and give it a name based off of the current Unix timestamp. So that's what we're going to be doing for today's particular project. So there's no major warnings for today's particular project, just a couple of things to be thinking about. So when you're dealing with a 5 megapixel Arducam, one of the things that you do have to realize is that the processing power for this particular camera is not very high. So when it takes a picture, it takes a while to take a picture. And so if you set the resolution high, if you have any kind of motion within the frame for that picture, you're going to get a lot of blurring. So basically, the higher the resolution you have, the longer it will take for the picture to actually process. And so if there's motion, the more blurring you will have. You can modify the resolution for the Arducam, so you can modify it all the way down to be a very small picture. If it is a small picture, the resolution will be lower, but it will be very fast. So if there is motion within the frame, you won't get nearly as much blurring. So one of the things you have to think about is, do you want a really high quality picture and possibly have a lot of blurring in the image? Or if there's going to be a lot of motion, maybe having a smaller resolution picture will be better, and then you'll get less blurring. It's just kind of one of those things that you have to think about. Again, with many things in the Arduino and the technology world, there is no right or wrong answer. It's just for your particular situation, determining what resolution is best is just something that you will have to figure out. Beyond that, we are also going to be using a real-time clock. So when we take the picture using the Arducam, basically we're going to have the picture, and then in order to name that picture, we're going to take the Unix timestamp. We're going to chop off the first 2 digits, the 1, 5, and then the last 8 characters we're going to use. We're going to have a period, and then we're going to add on a JPG. So when you're using an SD card in the Arduino world, it uses the 8.3 naming convention. What that means is you can have 8 characters in the front, you can have a period, and then you can have a 3-character extension. So how we're going to be naming our images for this particular project is by using the Unix timestamp and simply ripping off the first 2 characters. So we are going to need the real-time clock in order to name the JPEG images for this project, and we're also going to be using it to track the time lapse. So for what we're going to be doing today, we're basically going to wait every 60 seconds. So what we're going to do is we're going to take a look at the Unix timestamp. As that Unix timestamp is 60 seconds away from the last time we took a picture, we will then take a picture again. So if you don't have a real-time clock on your particular SD shield, your data logging shield, you will have to add a real-time clock to make this particular project work. So that's really all the warnings that you have to be thinking about today. So with that, let's go over to the demonstration computer. I will show you the results of what this particular project looks like when you put it out there. So what I did is I basically put this out by my pond out back and basically walked away from it for about an hour and a half. And so every minute it was taking a picture. So we'll take a look at those images. Then I will show you how to actually physically build this project, and then we'll take a look at the code. Okay, so here we are at my demonstration computer. I have put the SD card into it, and we can see these are all the JPEG pictures that have been taken. So we'll notice with the name, we can see 917-90585. So essentially this is the Unix timestamp with the 15 in the beginning ripped off of it, .jpg, and that is how we get this name. If we go over to a different view of these images, we can get a bit of an idea of what this will look like. So if we go to the beginning, we can see that this is the first picture that was taken. Let me maximize this so it's a little bit easier to see. And then what you can do is you can scroll through, and basically you can see that every minute another picture was taken. So as I scroll through pretty quickly, we get something that looks like an old-timey movie. So again, this can be useful if you have a construction site or possibly for a garden. So think about putting the camera in front of your garden, and so as different things grow, basically again, it can take a picture every minute or every 5 minutes or every hour, something like that, and then you can create some kind of interesting video file or something based off of that. So this is basically what the project is going to look like once you have actually built it. Again, using the 5 megapixel camera, you can take a look and see what the resolution is actually like. If I zoom in here, so I have a little mermaid statue sitting in my pond, and so you can zoom in and you can start to get an idea of the quality of this particular camera when you're doing the full resolution. So this is the highest resolution that it offers, and so you can see that, you know, from a distance away where that mermaid is, you can zoom in and you can get some better features off of it. Again, this is going to be something that you have to be thinking about when you start using cameras in your IoT projects, is making sure that the camera takes the quality of picture that you actually need. A lot of times people simply throw cameras into the field and then they don't think about how low the resolution is until they actually need the picture, and then they go take a look at the picture and they realize that they can't tell what's going on in the scene. So you are going to have to think about the quality of the image that you want to take whenever you're going to be designing your projects. But so this is what the Arducam looks like. One of the nice things here, you can see the file size of this. So this is 1.4 meg. So the cool part is the SD card that I have in this Arduino project is actually a 64 gig SD card. So at 1.4 meg, you can take a whole metric crap ton of pictures, right? 100,000, I don't know, 60,000 or something. A lot. You can take a lot of pictures. So again, something to be thinking about is you put this into an environment like a garden, or again, maybe if there's a large construction project, something like that. If this has a power supply, you could literally plug this in, walk away from it for a month or two, come back, grab the SD card, and then you can have the time lapse for a tremendously long period of time. So that's just one of those things to be thinking about. So with that, let's go over to the workbench. I will show you how this project is actually built, and then we'll go take a look at the code. So this is the physical build for the project. There's really not a lot to it. We have the Arducam, we have the Arduino Uno, and we have the data logging shield. The big thing with the data logging shield is, again, is that it has the real-time clock, and then also for the Arducam, we are going to need the SCL and the SDA pin. So do make sure that whatever data logging shield you're using, the SCL and the SDA pins go all the way up into the data logging shield itself. If not, you're just going to have to modify your wiring a little bit so you can plug the Arducam in. Beyond that, the only other real, customization that I've done is I have plugged the Arducam into a breadboard, and so this way it's a lot easier to position and aim the Arducam for your project. Honestly, it can be a real problem. If you simply have the Arducam plugged into the wires on the Arduino, it can be a real pain to figure out how you can actually aim and move the Arducam around. By simply having this plugged into the breadboard, especially when you're playing around and you're testing, this just makes the life a lot easier for being able to do positioning and all that kind of stuff. There's really nothing to it. All of this is just the standard default cabling for the Arducam. You can go take a look at the wiring diagram for that. There is no additional modification for this particular project. So with that, let's go over and take a look at the code and see how this project is actually built. So here's a sketch for this particular project. What I've done is I've modified one of the examples that comes with the Arducam library. So the Arducam Mini 5MP Plus Multi-Capture 2SD. This is the example that I have modified. Most of what you see in here is simply a copy and paste from that example, and then I've put in my own particular edits. Up here, we're going to be including the libraries, the wire, the Arducam, the SPI, and the SD. Those are just part of the example. And then we're going to be including the memory saver configuration file. Important thing with the memory saver configuration file is that you actually define which camera and module that you're using. So here, basically what you do is you uncomment out the camera and module that you're using so that the sketch knows what to use. So select the hardware platform. So we're using the OV5642 Mini 5MP Plus. So this has been uncommented out. And then if we scroll down, we can see that here, select one of the camera module. I'm using the OV5642 cam. So these have been uncommented out. Just go take a look at the receipt or take a look at your particular camera to figure out which ones you're using and set that up and then save that. Then we're going to go down. The first thing that we're going to do here under ETCG notes is for frames number, we are going to set this to 1. So 0x00 means it will only take one picture every time the Arducam is called. For whatever reason, the standard or the default is like 5 or 6 pictures. And so basically I've just set this to 1. So every time we call the Arducam, it will only take one picture. Here for CS equals 7, this is for the wire from the Arducam that is actually connected to the Arduino. You can put this to different digital pins, but the default is 7, so we'll just leave that with 7. Then, as one of the notes, this is for the SD module or shield. So for your SD, your data logging module or shield, if you're using a shield, there will be a hardware-defined pin that shield will use for communicating with the SD card. So for this high let-go shield, that is pin 10. So this is hardwired into the shield itself. So I have an Ethernet shield that I use, and that also has an SD card slot on it. For that Ethernet shield, it uses digital pin 4. These are just hardwired into it. So if for some reason your SD card isn't working properly, go take a look at the information for your shield and make sure that you're using the right digital pin here. Past that, we're going to go down. This is a setup for the real-time clock. So we're using the rinky-dink real-time clock library like I do for most of my projects. So we're including that library here. We're creating the real-time clock connected to SDA and SCL, just as a normal setup for the real-time clock. Then we're coming down here and we're creating a time-lapse length. So basically what this is essentially how long do you want to wait until you take a picture. And this is in seconds. So this is an int, since it's seconds, and we're simply setting this to 60. So every minute it will take a picture. If we wanted to take a picture every 10 minutes, you would set it to 600. Again, you can set this to whatever you want. Go from there. Then we're going to have a long, and this is going to be the lapse timestamp. So essentially every time a picture is taken, what we're going to do is we're going to take the Unix timestamp for the real-time clock, and we're going to assign that value to this variable. And then we're going to check against that variable until 60 seconds has passed. Then basically once 60 seconds has passed, we'll take the picture again. We will reassign the lapse timestamp variable value and go from there. Then finally, for this is where we're going to create the file name, or basically we're going to create the variable for the file name. So we're just simply going to do string and file name. So again, we're going to be creating a file name based off of whatever the Unix timestamp is. And so we're just creating that variable name here. Then we're going to scroll through. Again, just don't mess with it, 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 don't mess with any of this until we come down here to the loop. And basically once we're then into the loop, the first thing that we have to do is we actually have to begin the real-time clock. If we don't begin the real-time clock, we can't get the timestamps. So we essentially begin that here. And then we're going to come down here, and this is where you can change the resolution of the JPEG, right? So basically with the Arducam, you can change the resolution for the camera, and that is what is set right here. So this whole thing here, OV5640 underscore 2592 by 1944, these settings here, this is where you set the resolution. Now if we go over to my demonstration computer, basically if you look at the facts, if you look at the information for the shield, I will have the link for this in the notes for this particular video. This is where you can go through and you can see what resolutions are available for your particular camera and module, and then you can see what you have to do to plug that information in between the parentheses. So if you wanted a 1600 by 1200 and you're using the 5642, so you do OV5642 underscore 1600 by 1200, and that would give you that particular resolution. If you want the smaller resolution, 320 by 240, this is what you would plug in right here, so on and so forth. So basically that information is there. Again, the smaller the resolution, the faster the Arducam will be able to take the picture, the less blur, but obviously the poorer quality, so you have to figure out what resolution you want. Past that, we're just simply going to go down, and then this is where we decide to actually take a picture. So this isn't that complicated, it just looks a little bit ugly. So what we're going to say is if. So if the current Unix timestamp minus the lapse timestamp is greater than time lapse length, so this is 60, right? So basically, if I subtract lapse timestamp from the Unix time and it is greater than 60, then we want a picture to be taken. So when we take the picture, the first thing that we're going to do is lapse timestamp is going to be set to whatever the current timestamp is. So basically that locks that into the last time a picture was taken, and then it's going to continue as it loops through. It's going to say, okay, the last time a picture was taken minus the current time, is that above 60? As soon as it's above 60, it will trigger this loop to happen. Then we're going to go through here, and again, we don't modify any of this. This is basically how the picture is taken. So all of this code here is required to actually take the picture. Else, so basically else, so if it's not greater than 60, we're going to serial print out. So we're going to serial print to the serial monitor. And what this does is this basically just gives us a countdown. So it'll tell us how long. So 40, 39, 38, 37. So as it loops through, that's what it's going to be telling us. So what we have here is a real-time clock. So basically the Unix timestamp minus the last time, the lapse timestamp minus time lapse length. So basically you do all this, and basically that gives you the countdown until the picture will be taken. I'll show you that in the actual serial monitor itself. Past that, we're then going to scroll down. Basically none of this we are going to modify until we get down to the file name. So we have the etcg node here. Basically we're going to create a file name for the image. So we're going to create that file name based off of the Unix timestamp. So we're going to have a long for timestamp. Timestamp is going to equal, this is the Unix timestamp, the function for getting the Unix timestamp. Then timestamp is going to equal timestamp minus 1.5 billion. So essentially this is an ugly way, this right here is an ugly way to get rid of the first two characters. So again, when you're saving to an SD card in the Arduino world, you can only have 8 characters in the beginning of the name. So basically to remove those first two characters, I'm literally simply subtracting them out. It's about a bit of an ugly, blunt way of doing it, but it works. Then what we're going to do here is file name is going to equal the timestamp. So again, timestamp started as a long. So we're now going to turn timestamp into a string, and then we're going to add .jpg to the end. And then out file, so we're going to do sd.open, that new file name that we've created. We're going to write create truncate. And so basically that is going to be written to the SD card. And so that is how this code works. So with that, what I'm going to do is I'm actually going to plug the Arduino into the computer, and then we're going to go to Tools, and we're going to go to Serial Monitor. And so with the serial monitor here, we can see Arducam start, SPI interface OK. The module has been detected, but then we get the SD card error. We're getting the SD card error because we have not plugged in the SD card. So I'm going to plug in the SD card. We can see SD card is now detected. It is then going to start capturing the picture, and it's going to give us some information here. It's going to take us, it takes about 20 seconds for the full image capturing process to work. So if it delays here, don't think it gets locked up or anything. It just takes a little bit for the process to work. So it's going through, it's taking the picture, it's saving the picture, and now this is where we're counting down. So waiting 42, 41, 40. So we're having that nice countdown here. Again, from a troubleshooting process, this shows you that the system hasn't locked up, the Arduino hasn't locked up, you're not getting some kind of weird problem trying to save an image file or something like that. This is just a nice little troubleshooting routine here just to show you that, yes, we are actually counting down. And so from here in about 15 seconds, it is going to take another picture. So as I sit here and I waste another 10 seconds of time just waiting for it to take a picture, as I say, it's going to count down, count down, count down, count down, and then when the time is above 60, it's then going to start the capture again, and so it is now taking a picture. So that is basically how this project works. That's how the project is built. That's what the code looks like, and this is what you're going to be taking a look at on the serial monitor when you have put all this together. So there you go. Now you know how to create your own time-lapse camera using an Arducam and an Arduino. Now the cool thing about using an Arduino to create a time-lapse camera is you can add like other variable values, you can add other sensors, be able to test against those other values to actually have the picture take a picture. So something to be thinking about, like let's say, again, you want to take pictures of your garden growing. Well, obviously with a kind of crappy camera like this, once the sun goes down below a certain level, it's not really going to be able to take very good pictures. So you don't want half of your pictures literally in the dark. So one of the things that you could do is you could put a sunlight or a light sensor onto this particular project. And if the light is above a certain level, it will do the time lapse and it will take the pictures. But if the light goes below a certain level, it will stop taking pictures. Why create thousands of basically black pictures, right? That's one of the cool things you could do with a project like this. Or think about a construction site. So let's say you want to do a time lapse of a construction site as a house is getting built or some project is being done. You don't necessarily want to take pictures when nobody's at the construction site. So using the real-time clock, you could set the variable values and basically say if the time is past 7 o'clock in the morning, Monday through Friday, and before 5 o'clock at night, then take the time-lapse images. But if it's outside essentially of working hours, don't bother taking those time-lapse images, right? That's the cool thing about the Arduino, is that you can add on these other sensors, you can add on these other variable values, and then you can make a much more sophisticated project than simply taking something like an old iPhone and setting it up and having to take pictures. Again, one of the cool things with this, even with a 5 megapixel camera, is the images that it takes, the pictures it takes are only like, 1 to 1.5 megs in size. So again, if you put a 64 gig SD card into a little project like this, you can literally plug this in, walk away, and I don't know, back of the napkin math, I figure that would probably take, pictures for a month or two. And so literally, again, with a garden growing, let's say in springtime or something like that, you could plug a project like this in, walk away from it, forget about it, come back to it 2 months later, pull out the SD card, and you could have this really nice, this time-lapse shot of your garden growing and the flowers dying and the next thing's coming on, so on and so forth. So I think this is a pretty cool project. Now, to be honest with you, again, using an Arduino in order to run an Arducam, it's a little bit of a push, for the Arduino. The Arduino really doesn't have a lot of resources. It really doesn't have a lot of power. So you will run into some problems using an Arducam with an Arduino if you really try to do things that are too sophisticated. So that is something you need to be thinking about is it really best for your project to use an Arduino, or should you be using a Raspberry Pi, something else? That's just one of those kinds of things that you have to play around with, think about. But I think this is pretty cool. So this basically allows you to add a pretty nice camera to your IoT projects and gives you some new things to play with. As always, I enjoy doing this class. Look forward to seeing the next one. If you like the content that I create, please think about going to elithecomputerguy.com and becoming a member or donating. Please understand that all of the educational videos are in front of the paywall. That includes the videos, that includes the notes, the diagrams, and the code example. All of that is freely available and in front of the paywall. But if you want to watch opinion videos, or if you want to be able to comment, you do need to become a member. Membership is $5 a month or $60 a year and gives you access to those opinion videos and the ability to comment. If you don't want to become a member, you just want to give a one-time donation, there's also a donate button where you can do that. Please understand, in order to provide the education that I am, it does cost money. Servers cost money, equipment costs money, travel costs money. All of these things cost a reasonable amount of money, and the fact of the matter is YouTube's advertising program no longer supports creators the way that it used to. So if you want these classes to continue to stick around and you find them to be valuable, please think about either becoming a monthly member or donating a few dollars for this project.